In this session, we will learn about another cryptographic concept, that is digital signature and its application in blockchain technology. The internet is an open and public system. We all receive and send information over shared wire and connections. And even though it is an open system, we still exchange a lot of private data like bank information, credit card details, email, password, etc. So how can we keep secret our private stuffs over internet? Data can be kept secret through a process known as encryption. It is a process of scrambling or changing the message into ciphertext to hide the original text. Now, decryption is a process of unscrambling the ciphertext to its original text. So, in cryptography, a key is a string of characters used within an encryption algorithm for altering data so that it appears random. Like a physical key, it locks the data so that only someone with the right key can unlock it. Now, there are some properties of cryptographic key. The first property is truly random. That means we need to generate the key truly random so that the attackers can't guess it. Secondly, the key should be of sufficient length, and if we increase the length, it makes the key difficult to guess. And the third point is entropy. That means the key should contain sufficient entropy. All the bits in a key should be equally random so that some parts of a key should not be guessable. Now the idea is very simple. People have been doing this for centuries. One of the well-known method was Caesar cipher, named after Julius Caesar. He used to encrypt his military commands to make sure that if his commands were intercepted by enemies, they would not be able to read it. Caesar cipher is an algorithm that substitutes each letter of an original message with a letter a certain number of steps down the alphabet. If sender and receiver only know that number, then it is called the key. For example, if we take the word block, B-L-O-C-K, and the step down number is 4, then the word will become F-P-S-G-O. Right? Now the problem is anybody can crack the message by trying with every possible key, and it will take hardly an hour to crack. Now, how can we encrypt messages so securely so that they are too hard to crack? Now, too hard to crack means there should be too many possibilities. Now, today's secure communications are encrypted using 256-bit keys. That means if a bad guy's computer that wants to intercept your message, it would need to try so many possible options. Even if you had 100,000 supercomputers and each of them are able to try a million billion keys every second, it would take trillions and trillions of years to try every option to just crack a single message protected with 256-bit encryption. But today's impossible problem will be solvable just a few hundred years in future, and maybe the 256-bit algorithm will not be enough to be safe. Now, in private key encryption, data is encrypted using single same key that only the sender and receiver know. Private key encryption is also known as symmetric key encryption because the same key is used in both encryption and decryption of the data. To explain this, let me introduce a typical example of Alice and Bob. Bob wants to send a lovely message to Alice. He does not want anyone else to see it, so he encrypts his message. Well, this is easy because Bob shares same key with Alice. So they use the same key to encrypt and decrypt the message. The main drawback here is the chicken and egg problem of sharing the secret key. Without a secure channel, the key cannot be shared, but without the key, no secure channel cannot be created. So you need to have a way to get the key to the party with whom you are sharing the data. In asymmetric encryption system, users generate a key pair, a public key and a private key. The public key and the private key are associated with each other through some mathematical relationship. The public key is meant to be distributed publicly to serve as an address to receive message from other users, like an IP address or home address. The private key is meant to keep secret to the user. Now, here is an example that can demonstrate the asymmetric key cryptography. Bob is sending a lovely message to Alice. They agree to use public key encryption to encrypt his message. Here the encryption process starts with receiver Alice. Now, how does it work? First, Alice creates a pair of keys, one public key and one private key. She keeps the private key with her own and put the public key in the public key server, which anyone can access. Now, Alice also informed Bob that from where he can get her public key. Now, Bob gets her public key. After that, Bob writes his message. He uses Alice's public key to encrypt it. And when Alice gets this message, she uses her private key to decrypt the message. Now, please keep in mind that public key encryption method is started by the receiver, not by the sender. Here, Alice generates two keys initially. Now, although Alice's private key verifies that no one can change or read the document during transport, but it cannot verify the sender. Because Alice's public key is public, anyone can use it to encrypt his document and send it to Alice while pretending to be Bob. In order to prove the sender, they need another technique called digital signature. Now, what about digital signature? It is like a real signature. It is a way to prove that a message originates from a specific person and no one else, like a hacker. It is more secure than handwritten signature that can be easily forged. From digital signature, we use today all over the internet. Whenever you visit a website, you are using SSL connection, which uses digital signature to establish trust between you and the server. This means when you visit gmail.com, your browser can check the digital signature that comes with the web page to verify that it is indeed originated from Gmail and not by some hacker. So, digital signature serves three purposes. First is message authentication. That means digital signature gives the receiver reason to believe that the message was created and sent by the claimed sender. Second point is non-repudiation. That means with digital signature, the sender cannot deny having sent the message later on. And the third point is message integrity. That means a digital signature ensures that the message was not altered during transit. Now, there are some common uses of digital signature. It is mainly used in financial transaction, in case of software distribution, where forgery and tampering can be detected easily. Now, digital signature uses the public key encryption technology. Here, the message is signed using the private key, and again, message is verified using the public key. Now, let me demonstrate how digital signature works. First, Bob generates two keys, one public key and another private key. Now, Bob keeps the private key and gives public key to the receiver Alice. Now, first Bob creates a memo. After creating the memo, Bob generates a digest using hash algorithm. Bob encrypts the digest with his private key using asymmetric cryptographic algorithm. Now, encrypted digest is called the digital signature for the memo. Then Bob sent both digital signature and the memo to Alice. Look, the memo is not encrypted. While Alice receives that, she will do two things. First, Alice decrypt the digital signature using the public key of Bob and get the digest. If Alice failed to decrypt the digital signature using the public key of Bob, then it is confirmed that this is not Bob's digital signature, because only Bob's public key can decrypt the digital signature to get the digest. Secondly, Alice will check the integrity of the memo. For that, Alice will hash the memo by the same hash algorithm and generate the digest. Now, Alice will compare the generated digest along with the digest received. If both matches, then it confirms that the memo is not altered after Bob sent it. But if it doesn't match, then memo has been altered in transit. So, in blockchain technology, the generating a key pair is analogous to creating an account on blockchain, but without having to actually register anywhere. Also, every transaction that is executed on the blockchain is digitally signed by the sender using their private key. This signature ensures that only the owner of the account can move money out of the account. So this is the concept on digital signature in the blockchain technology. Thank you.